So we want to review section 10.4, what we did in class today. Section 10.4, Inscribed Angles. Okay, so what I want to do is take us through some things that we have had before with our angles and circles, and then we're going to add some new. So the first thing we want to do is a little review piece that we had. So let's look at a circle. Okay, put a little circle up here. Oops. All right. So we have our little circle, and we're going to name that circle Circle A. There's our circle. And in this circle, we're going to put an angle that has as its vertex the center of the circle. Therefore, we have created a central angle. Angle A is a central angle because its vertex is the center of the circle. So when I look at angle A and the arc that it intercepts, I know they have a relationship that we have talked about before. The measure of angle A equals the measure of its intercepted arc. And I have zigzagged in the intercepted arc in red. This is the intercepted arc. The intercepted arc will lie between the two sides of the angle. So you see how I've got one side and the other side. So my intercepted arc lies in between. If my central angle has a measure of, let's say, 47 degrees, then that means that my intercepted arc from, let's just call it from X to Y, then that means that the measure of arc XY is also 47 degrees. And that's something we've done before. Now let's go a little step further. I want to get another circle up here. Okay. Let's say this time that we put the vertex of the circle on the circumference itself. And we're going to put an angle in here. I'm going to call this vertex B. Okay, and we're going to cross out here again at XY. This time my intercepted arc is this little piece that I'm squiggling in. Again, it's the piece that's in between the two sides of the angle. An intercepted arc, or I should say an angle that's on my circle like so, angle B, is a inscribed angle. That means its vertex is on the circle. And they have a relationship as well, the measure of the angle and the intercepted arc. The measure of the angle is going to always be, when it's an inscribed angle, when it's inscribed, it's going to be 1/2 the measure of the intercepted arc. So if my angle is 30 degrees, then my arc is 60 degrees. Now we're going to use this concept to look at something else that we've talked about before. Let me get another circle up here. I'm going to go back up to the top of the page. If I have a circle, and again, let's put in a diameter this time. Let's see if we can put a line across there. Okay, there's a diameter. If I take my circle, and this time I put an inscribed angle inside this semicircle. Now when I do that, remember inscribed always means that the vertex is on the circle. So this time I'm inscribed in a semicircle. So my vertex is on the circle, and the sides have to go through the end points of the same diameter. We've seen this before. We say then that angle C has to be a 90-degree angle. So if I have an angle inscribed in a semicircle, then that angle is a right angle. Now let's let that make sense with the work that we did over here about having an inscribed angle being half its intercepted arc. If you'll look at this particular diagram up here, the top circle that we're working on, notice that angle C intercepts this arc. I'll squiggle it in again. So angle C's intercepted arc is a semicircle. I don't know why that's wanting to not write very well for me. Okay. Angle C's intercepted arc is a semicircle. So since that an inscribed angle is half its arc, and since the arc is a semicircle, so that makes it 180 degrees, that means any angle inscribed in a semicircle is going to always be 90 degrees. Okay? Does that make sense? All right, so let's continue. We'll move this up a little bit. Pick up a couple more ideas. Okay, so we've got a central angle equal to its arc, an inscribed angle 1/2 of its arc, so that means that an angle inscribed in a semicircle is going to be 90 degrees always. We also need to look at another situation. Let me get a circle up here. Let me make it a little bit bigger this time. Okay, now, if I have a circle this time, and I have inscribed inside of that circle a quadrilateral. Now remember, a quadrilateral has to have 4 sides, so I didn't say a polygon. I said this is a 4-sided figure. And since it's inscribed in my circle, that means that each of the 4 vertices is on the circle. So I have, we'll just call this A, B, C, and D. if I have a quadrilateral inscribed, again, that means that all four vertices are on the circle, in a circle, then the opposite angles are going to be supplementary. So that means that the measure of angle A plus the measure of angle C, since they're opposite one another, they will add up to 180 degrees. That does not mean they're going to always be equal to each other. Their being equal is one scenario, but it is not the most common scenario. Okay, likewise, I've got angle B and angle D. Supplementary. Okay, so I've got both pairs of my opposite angles in an inscribed four-sided figure. Those are going to be supplementary to one another. Okay, and again, we're in 10.4, and I'm doing a little double check to make sure that I've covered all the rules we talked about today. I knew I left out one. There's one more to look at. Okay, so guess what? We get to make another circle. Now, if you'll remember, just a few minutes ago, we said that when we put an angle inside a circle and the vertex is on the circle, in other words, when we have an inscribed angle down here, I'll call that angle F, and you see how it intercepts this arc out here. Again, I'm going to call my arc XY. Okay, when I've got that situation, I need to change colors, don't I? That's not showing up really well. When I've got that situation, I might have another angle in that same circle that intercepts that same arc. So I could have an angle G down here. Since both angle F and angle G are inscribed angles, and they intercept the same arc, then that means those two angles must be equal to each other. And let's look at that with some numbers. Let's say my arc measure is 40 degrees. Okay? Since F intercepts that 40-degree arc, then that means that F is half of 40, or 20 degrees. Since G intercepts arc XY, and it's still 40 degrees, G is half of 40, so it must be 20 degrees. So when the same arc is intercepted by two separate angles in the same circle, then those two angles must be the same measure.